The cell wall of this wood is made up from cellulose. The whitish part here is a cellulose, so you can turn this cellulose into a paper. The cell wall for this oyster mushroom is made up from a chitin-glucan complex. Whether it's a cellulose or chitin-glucan complex, both offer structural integrity to its parent organism, be it wood or a mushroom. Being a structural material allow us to extract this natural polymer and use it in many applications, whether in membrane technology, in food technology, in packaging, or in biomedical application. In this video, we will show you step-by-step process on how we extract chitin-glucan complex from 2 kg of oyster mushroom or grey oyster mushroom. Bear in mind that whenever we talk about chitin from mushroom, actually it is chitin-glucan complex. But throughout this video, we will say chitin or fungal chitin. But note that it's actually chitin-glucan complex. Before we jump into the practical part, let's talk a little bit about the theory behind the extraction process. To extract chitin-glucan complex from this mushroom, there is 3 steps. The first step is hot water extraction. The second is alkali deproteinization. And the last step is neutralization. So, the hot water extraction, the purpose is to remove any soluble material inside this mushroom. We use 85 degrees Celsius for 1 hour for that step. And the second step is alkali deproteinization. The purpose is to remove all the proteins and unwanted organics. So we do that step at 1 molar sodium hydroxide and 85 degrees Celsius for 3 hours. And then we just wash the thing until it neutral using a tap water, and we rinse with the distilled water at the end of the day. We maintain 1:40 solid to solution ratio during our extraction as our working volume. This allows us to scale up or scale down our extraction, whether it's 1 kg of mushroom or 10 kg or 100 kg of mushroom, then it's okay because we have a standard ratio proportional to whatever we want to extract. The reason why we use 140 is because when you try to blend the fresh mushroom, first it will become very thick, it will become very viscous, and it's very difficult for you to stir if, let's say, the solution is very thick. So that's why we use 140. Another reason is because we want to maximize the reaction between the solute and also the solution, the extractant solution. So that's two of the reasons of the 140 ratio. However, mushroom is mostly made up of water. This grey oyster mushroom is 90% is water and only 10% is dry matter. So if let's say I have 2 kg of grey oyster mushroom, then 10% of it, meaning that it's 200 gram of dry matter. So according to our 140 ratio, 200 gram times 40 is equivalent to 8,000 gram. So that's approximately 8 liters of water. So during our hot water extraction, we will use 8 liters of water. So that's what we mean by 140 ratio. And then subsequently for alkali deproteinization, we will follow that 8 liter working volume. Once we're done with all that, we just wash it with water until it's neutral. So it's fairly straightforward process. But let's see the practice of it. At the end of this video, we will share to you how much chitin that we got from this 2 kg of fresh oyster mushroom. Let's see the practice. So for extraction process, we need to know first our working volume. So here we have 2 kg of mushroom, equivalent to 200 gram of dry solid, because the dry weight for this mushroom is 10%. So the working volume that we will use is based on the ratio 140, 1 solid, 40 liquid. The reason why we use 140 ratio is because to facilitate the steering during the extraction process. Because if we use a lower ratio, say 1 to 10 ratio, then the slurry will become too thick and it's difficult for what we call for the extraction to happen, for the steering to happen lah. So because this is 200 gram equivalent to 200 gram solid, so we time with 40 is equivalent to 8,000 gram of working solution, or equivalent to 8 liters 8 liters solution during the extraction process, whether it is during hot water extraction or alkali extraction. So for that 8 liters capacity, we need a big beaker. So this is our pot, the standard pot. So we use this standard kitchen pot. Typically the grade for this stainless steel is 304, and 304 grade of stainless steel is good enough to handle the alkali condition. Okay, so it will not corrode this this pot during our alkali extraction later on. So we have two here because to make it easy. For example, let's say we want to prepare our alkali here, then we can, while doing that, we can do other stuff here. Okay, so this is the pot. So the size here, I think this is 15 centimeter by 15 centimeter. This volume for this pot is around 12 liters. Okay, so it's enough to sort of like to handle 8 liters of working volume. And also we prepare our consumable and also all our apparatus in advance to make our life easier. So you need to make sure you have the plastic bag and also the marker. The use is to store our fresh mushroom, and obviously you need a glove, and also this is distilled water we put in this spray form to make maybe we want to spray something. And then we also have in this wash bottle form, this too is a distilled water, and we also have the ethanol here, and also we have the sodium hydroxide as our chemical, because this is a chemical used during our deproteinization step. Okay, so hot alkali extraction step. Okay, and this normally come in 1 kilogram batch. For this to extract this, you need to use around 320 gram of alkali, the sodium hydroxide. So you need to make sure before you even attempt to extract this whole batch of mushroom, 2 kilogram of mushroom, you need to make sure you have enough chemical left. Okay, and also we have the petri dish, this for dry weight purpose. And because remember we said we use 8 liters volume, then we need to prepare the distilled water, enough distilled water in advance. 8 liters working volume for hot water extraction is one thing. So you have 8 liters, and then 8 liters volume for alkali extraction is another thing. So you have another 8 liters, and then for washing, for rinsing, maybe let's say another 5 liters. So total up, you for this project, for extracting chitin from 2 kilogram of mushroom there, it's good to have to be ready with 25 liters of what we call the distilled water. Okay, and obviously you need a balance to measure our mushroom. And also for thawing purpose, we use this what we call this bucket. So you just put the frozen mushroom here and then run the tap water on that to thaw. And we have also the strainer here, so this will facilitate the thawing. And then obviously after thawing, we will blend our sample. So we have high-speed kitchen blender here. Okay, so after we blend our sample, we put inside this what I call this pot. We will need to heat it up, okay, to start our hot water extraction and also alkali deproteinization step. So for that, we need to make sure we make everything ready in the fume hood. So this our hot plate, okay, the magnetic steel hot plate. So here, one important thing about this is that because you use 8 liters of working volume, remember this thing alone is already weight about 1 kilogram. So if you add 8 liters of solution here, so it's already around like 10 kilograms. So you need to know the spec of your hot plate. because you need to make sure that your hot plate can sort of like sustain this the very high weight of thing on top of it. So this hot plate rated able to sustain about 15 kilogram of the weight on top of it. So for 10 kilogram roughly is okay on that. Okay, and of course when you use this what we call the large pot like this compared to this small like 2-liter beaker, you need to make sure that you get a good enough steering. So if you use like a typical steering bar, magnetic steering bar, and also your mushroom slurry later on will become too thick, then it might not stir effectively. That's why we have this what we call the overhead stirrer here to facilitate our steering. So here we use a pedal type of stirrer, so it's allow the tangential mixing flow because that is recommended for if you have something very viscous like mushroom slurry and so on. This type of stirrer pattern is advisable lah. And also you have temperature probe here, and then make sure you're also ready with the timer, so it will help you during the extraction process. It will sort of like help you in keep track of your time. So I think that is apparatus that you need to prepare well in advance before you even start what we call doing the extraction process. For extraction process after hot water extraction and also during neutralization process, we will use this setup. So let's see. So we have here the filtration setup. So it connected with this pump. So the pump, you have the hose here, and then we have this buncher funnel. We will use a big one. So this is about 250 mm in terms of diameter. We use the big one because we use a lot of sample, and we use our stock pot here. This is 20 liter, I think 20 liter stock pot, and then on top of the stock pot we made our own O-ring using a silicone, and then we have the perspex here, and on this perspex we also put some opening here connected to the hose there. And here we have this what we call the rubber, so that it can sort of like seal our buncher funnel. We also make sure that we have this ready, because this can sort of like we can put our buncher funnel here without it tipping off. And also this our sample container. We also have this scraper. So after we get our chitin later on, we will scrap this out of the filtration cloth. So for the filtration cloth, we use this normal clothing. Any clothing can be sufficient. So the size for this cloth is about what we call, is around 70 centimeter by 70 centimeter. But the size is dependent on your buncher funnel lah. So our buncher funnel here, the reason why we use that size is because we can sort of like put our filtration cloth so that it can fit until the bottom and still left some what I call some leftover part here, so that it's easy for us to take it out later on. But in order to use this vacuum pump, this filtration setup, we need to make sure that the vacuum is working first. This pump doesn't have any gauge, so we don't know the vacuum for this pump. So in order to ensure that this will work well, we need to manually check whether there are vacuum or suction happen here. So we open this pump first, and then just simply using our hand, we put on the hole there. So if let's say there are some suction happen, we can say that the sealing is good enough lah. So here, so you can see there are some suction happen. So we can say that this is good enough to do the vacuum filtration later on. Okay, so we can close this first. So that is our filtration setup. We also have this, what we call the screw press. The purpose of this screw press is to compact our sample, especially after we got our hot water extract. Before we do our alkali extraction step, let's say we want to save that hot water extract, we use this to compact the sample, to remove the water and also compact the sample. Okay, so it's just simply a screw press, so you can just close like this and just use this to press the sample in the middle there. Okay, and you can see there are some hole here, and when it's pressed, the water will go flow and we ready with the basin to capture that filtrate. Because these are made from the cast iron, it's very important for you not to use any acid-based material because it will corrode this thing. And also, if you see at the bottom here, there are some corrosion, metal corrosion and so on. So in order to make sure that our sample not in contact with that corrosion, what we will do after we finish doing this filtration, we will take out our sample, and then we will zip tie it. We will use our zip tie there, and then after that we will put in the middle here. But in order to prevent it from being contact with the corrosion over here and there, we put another layer of what we call the filter cloth. Any cloth is okay, just to prevent it from in contact with the two. And then we take our sample, put in the middle, and then we layer it with another filter cloth. Okay, and then after that we can press it, we can close and press it, and then you get the filtrate coming out. And then after we done, we take it out, and then we take the thing out, and then now it's already compact with less water, and we can open this thing. We can lay out everything on whatever table, and then we can scrape it using this thing. We can scrape it and put in our in our container for the storage purpose. Yeah, I think that's it for our filtration setup. So this is how 10 kg of oyster mushroom looks like. So we bought it from a supplier, and then now we want to lay out everything, the 10 kg of the stuff on this table lah. So we put the this tissue paper on the table so that it can absorb some of moisture, because if you look here, there are some like moisture trap while doing transportation lah. So by doing this, we are trying to sort of absorb as much as moisture as we can lah. Okay, so this is how oyster mushroom, 10 kg of oyster mushroom looks like on the table. We use grey oyster mushroom, or scientifically known as Pleurotus pulmonarius. So let's see the close-up of this mushroom. So that's the gill. Okay. We typically repackage our oyster mushroom that we got from the supplier into this plastic bag, and we pack it in 400-gram package. The reason being is because 400 gram is the minimum amount of mushroom that we will use during our chitin extraction. For chitin extraction, it's important for us to know the dry weight of this fresh oyster mushroom, because mushroom is made up mostly out of water. The chitin from this mushroom comes from the cell wall, which is the solid part of this floating body. So when we do extraction, we need to make sure the ratio between the solid, which is whatever solid from this mushroom, and the solution, which is our water or our alkali during our extraction process, will be maintained throughout the batch of a batch. We don't need to dry everything, we just need to dry just a representative. So let's say the amount, the value that we got, the dry weight that we got from this, the average is around 10%, meaning that only 10% of this mushroom are solid and the rest is water. Then we can say that every batch here, on average, have the same dry weight, which is 10%. So when you got this dry weight, we can use that to control the ratio between the solid and the solution during the chitin extraction process. For dry weight, we measure the empty petri dish first, and then we just take our representative mushroom and just put on the petri dish, and then take note of the reading, and then we record our empty petri dish plus the sample. Okay, and then we repeat that for another 2 replicate B and C. We set our oven at 120 Celsius because we want all the water-based thing inside the mushroom, inside the sample, can be evaporated thoroughly. So we just let our sample here be dried in this oven until the weight of the sample becomes stable. I mean the weight of the dried sample becomes stable. Maybe it take 1 to 3 hours like that. Okay, once we left it in the oven for quite a while, we take it out. Make sure you wear the glove because it's quite hot here. So then we weight the beaker with the sample, dried sample, and then we jot down the value. After weighing the dried sample for about 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, and 7 hours, we found that our sample, our weight become constant throughout after like 6 hours like that. So after we calculate, the dry weight for this is about 10%, meaning that out of this original fresh sample, 10% of this are made up from the solid, and the rest, 90%, is just water. So that's how you measure the dry weight of your sample. Once we're done packaging our mushroom sample in this 400-gram pack, we will then put in our freezer. The reason why we put our sample in the freezer is because we want, during the slow freezing, the water molecule within this mushroom fruiting body will turn into crystal, and that will pierce or will poke into the cell wall of the mycelium or the hyphae of the mushroom itself. And that will sort of like facilitate our extraction process later on, because remember, the chitin is within the cell wall. So if the cell wall is disrupted during pre-treatment like this, then it will be much easier for that chitin to be exposed to the extraction solution during our extraction process later on.